Gateway Protocol, or BGP. And this is quite different than our other routing protocols that we've discussed, such as OSPF or EIGRP. The first big difference is that BGP is considered to be an exterior gateway protocol, or an EGP. Protocols like OSPF and EIGRP, they're considered to be interior gateway protocols, or IGPs. Here's the difference. An IGP routes within an autonomous system. An autonomous system is said to be a network under a single administrative control. For example, we're connecting out to a service provider's network. Well, our network would be one autonomous system, and the service provider's network would be a separate autonomous system. They're different networks under different administrative control. And here on screen, notice the two clouds representing the two different autonomous systems. We've got AS, or Autonomous System 64,500, and we've got Autonomous System 64,495. And an IGP is going to route within an autonomous system. But an EGP, like a Border Gateway Protocol, is going to route between autonomous systems. Now, like those protocols, like OSPF and EIGRP, we do form neighborships. We form a relationship between neighboring routers. We do have an option, though, by the way, with BGP, where we could have a neighbor that's not attached to us at the other end of a link. We could set what's called a multi-hop neighbor, but by default, the neighbor does need to be on the other end of a link. Just wanted to make you aware that there is a way to bend the rules a little bit and form a neighborship with a non-adjacent router. But when we're forming this neighborship, it is very different than OSPF or EIGRP. With those protocols, we send out hello messages using multicast, and we dynamically discover our neighbors. We automatically form these neighborships. That's not the way it works with BGP. With BGP, we have to, in the configuration, explicitly define the IP address of our neighbor, and when we set up this relationship with a neighbor, we're setting up a TCP session over which we're going to be exchanging route information. And that route information is going to consist of an address prefix and a length. In other words, the network address and how long, the length of the subnet mask. And we do that with OSPF and EIGRP, and we typically call that variable length subnet masking when we're advertising both the network address and the subnet mask length. But there's a new term for you here in BGP. When BGP sends this address prefix, the network address, and the length, which is the number of bits in the subnet mask, we call that information NLRI information, network layer reachability information. And the way BGP is going to make its path selection decision is quite different from OSPF or EIGRP. With OSPF, recall that we had a metric that was entirely based on bandwidth, and with EIGRP, by default, we just considered bandwidth and delay. There are a few other things we could consider, but that's what we consider by default. With BGP, it's very different in that we have many different path attributes, or PAs they're called. And these path attributes are going to be discussed in detail in our next video. But for now, just realize that we're not basing our path selection decision on something as simple as bandwidth. In fact, bandwidth is not even considered by BGP. And when we're categorizing different routing protocols, we would consider EIGRP to be an advanced distance vector routing protocol. We said that OSPF is a link state routing protocol. Well, BGP falls into its own category. BGP is considered to be a path vector routing protocol. The vector meaning that we don't have a map of the entire topology. We just know the direction that we go to get to a certain network. I'm going to send a packet to this next hop IP address as an example. But the path as part of the path vector, the path means when we look at our BGP table, we can actually see every autonomous system through which we have to transit in order to get to that destination network. We don't know the entire topology, but we do know the autonomous systems through which we're going to be passing in order to get to that destination network. And that's why it's called a path vector routing protocol. Now, in an upcoming video, we're going to take a look at a very in-depth example of a BGP configuration for IP version 4, and then we'll have another video where we set up BGP for IP version 6. But just to get us started, I want to give a really simple example in this video, just so that we have a good understanding of the basics, and then we'll build on that in upcoming videos. But let's go out to a live interface right now and set up exactly what we see in this topology on screen. We want to form a neighborship between routers R1 and R2, and we need to make sure between routers R1 and R2, and we need to make sure that we can exchange route information between those two BGP speaking routers. Let's begin our configuration on router R1. I'm going to go into global configuration mode, and let's go into BGP router configuration mode. And if you notice the topology on screen, I'm on R1. R1 is a member of autonomous system 64500. That needs to be part of my router command. It's not a process ID like we have with OSPF where I can just make up a number. It's got to match my autonomous system. I'm going to say router, BGP, and I'm going to give my autonomous system number of 64500, and we press enter. We're now in BGP router configuration mode, and we can set up a neighborship and advertise a route to a neighbor with just 3 commands. That's it. I just gave the first command. I went into router configuration mode. The next command is to point to my neighbor, remembering that we don't dynamically form a neighborship using multicast. No, we're going to explicitly state, here's the IP address of my neighbor. Here's the syntax. I'm going to say neighbor, and my neighbor's IP address is 198.51.100.2, and I have to say what my neighbor's autonomous system is. They're in remote AS, remote autonomous system, 64,495, and we press enter. That's command number 2 of 3. Now I want to advertise a specific network via BGP. To do that, I'll use the network statement. I'll say network, and the network that I want to advertise is that network between SW1 and R1, and that's a network address of 192.0.2.0. And for the mask, I don't give a wildcard mask, as we've done previously with other routing protocols. I'm going to give a subnet mask. I'm going to give the keyword of mask, and my subnet mask is a 24-bit subnet mask. So I'll say 255.255.255.0, and that's it. 3 commands, and we've pointed to a neighbor, and we said we want to advertise this network to a neighbor. Now, I need to do a mirror configuration on R2, so let's go over to R2 and give a very similar configuration. I'll go into global configuration mode and then into router configuration mode for BGP autonomous system at 64,495. And I need to point to my neighbor, which is going to be R1. I'll say neighbor 198.51.100.1, and the remote autonomous system, in other words, the autonomous system in which router R1 resides, the remote AS is 64,500. And we'll press enter. And in a moment, we should see a neighborship form. But I still need to advertise a network. I'm going to say network 203.0.113.0. Oh, and we see that an adjacency just came up. That's good news. And I'll say that this has a mask, a subnet mask of 255.255.255.0. And we're done on router R2. Let's see if we have really exchanged route information. Let's do a show IP route, first of all. Have I learned anything via BGP? Notice here the code of B means we've learned something via BGP, and it looks like we have. Here's the code of B, and this is for network 192.0.2.0/24. That's the network between SW1 and R1. We learned that via BGP. R1 advertised that to us. Now, if we want to see our BGP table, which shows all the routes that BGP knows how to reach, we can do a show IP BGP command, and BGP knows about 2 different networks. Notice that we did not advertise the network between R1 and R2. We didn't have to do that. I'm learning about 192.0.2.0 from a next hop of 198.51.100.1, that's R1. And to get there, I need to go into autonomous system 64,500, which is R1's autonomous system, and then from there, it's going to be internal to that autonomous system. What about this network? What about 203.0.113.0? Well, that's the network between R2 and SW2. That's within my autonomous system. Between R2 and SW2, that's within my autonomous system. So as we look at the path we see that it's strictly internal. I don't have to go into any other autonomous system. Now, this was a very basic example of BGP. We set up a neighborship, we saw how to advertise a network. We'll get much more in depth later on in this module, but this is a basic introduction. Now, let's take a look at our next video at how those path attributes work.